Part 2 of Lesson 5 of Chapter 2 is on solving rational equations. So if you look at this equation, we have to solve for x. What makes this problem difficult is that we have an x in the bottom of a fraction. And so what we're going to do is we're going to take this equation and we're going to multiply everything by the LCD. Now LCD stands for least common denominator. And so on this problem, my LCD is just x minus 8. So if I take that x minus 8 and multiply it times the first term, second term, third term, I'd get a new equation that looks like this. You'll notice that when I take that LCD times the middle term here, the x minus 8's cancel and you just get 6. So now I'm left with a quadratic equation. And now to solve that, we'd try to factor it. Unfortunately, this is not factorable. So if it's not factorable, we'd use the quadratic formula. And in using the quadratic formula, you can see that we'll get 8 divided by 2. And then inside that square root, we get 64 minus 24, which is the square root of 40. Well, the square root of 40 can be broken down into the square root of 4 times the square root of 10, which is 2 square root of 10. But since that's still being divided by 2, my final answer is 4 plus or minus the square root of 10. So I got two solutions. This would happen to be irrational. And sometimes they're not nice numbers. Sometimes it's not just whole numbers, integers. Sometimes it's irrational values. Second example of solving a rational equation, you can see same kind of problem. It's just a little bit longer and a little bit more complex. But on this problem, you can see that I've got three different looking denominators. And so when that's the case, typically one of them will be the product of the others. So you can see right here, we've got a quadratic, and we could factor that into x minus 4 and x minus 2. And so it's the product of the other two denominators. So now as you look at all three of these denominators, we determine that our LCD has to have an x minus 2, and our LCD needs to have an x minus 4. So now I'm going to take this LCD and multiply it by this term. And if I do that, everything cancels out and I just get a 4. When I take the LCD times the next term, you can see that the x minus 2's are going to cancel. So we'll be left with 3x times x minus 4. And when I take the LCD times the last term, the x minus 4's cancel. So we're left with 2 times x minus 2. This is now a quadratic equation that we can solve. We're going to need to get rid of the parentheses and move everything to one side. And as I move everything to one side, I get the quadratic 3x squared minus 10x minus 8. This is a quadratic that I believe is factorable. So what I'm going to do is I'm going to take the 3 and send it to the back. If I send it to the back, I get a quadratic that we can break down into an x minus 12 and x plus 2. But since I sent the 3 to the back, I have to divide these by 3. So we get x minus 4 and 3x plus 2, which means my two solutions are negative 2/3 and 4. Now one thing that we need to talk about is that on a rational equation, you have to identify any values that are extraneous. So if you look at this original problem, there's two values that we're going to label as extraneous if we get them for solutions. And that's 4 and 2. And why is it those values? Well, if you put those values back in, we'd get a 0 in the bottom of the fraction. Well, since we got an answer of 4, we have to label this one as extraneous. We did not get an answer of positive 2. And so we have one real solution, negative 2/3, and we have one extraneous solution at positive 4.